Okay, so let's have a look at a comparison here between two different types of average. So one of them is the arithmetic mean, and this is the one that we know just as the mean, where if you want to find the arithmetic mean of some data, all you do is you add together the numbers here, divide by how many there are. And then the geometric mean is kind of similar to this, but with multiplication instead of addition. So if you want to find the geometric mean of some numbers, all you need to do is multiply them all together. Then you take the nth root, where n is how many of them there are, and this is equivalent to multiplying them all together and then raising to the power of 1 over n. So we know lots of examples where it will make sense to look at the arithmetic mean, so we'll just have a look at one case where it makes sense actually to work with the geometric mean instead. Okay, so let's consider, imagine I make some profit one year, and then after another year, we'll say that my profit increases by 10%. And then we'll say that the next year my profit decreases by 10%. Okay, so first of all, let's have a look at what happens just with the arithmetic mean. So the arithmetic mean, 10% increase, 10% decrease. Because what you would need to do here is 10% plus and then minus 10%. So this is our 10% increase, our 10% decrease, and halve this, divide by 2. And this will give you with 0% change as our answer there, using the arithmetic mean. Okay, so let's compare this then to the geometric mean, where it's not so clear what do we do here. How do we compare these using the geometric mean? Can I do the square root of 10% multiplied by minus 10%? Probably not. But if we go to one side, let's think what happens if you increase something by 10% or decrease it by 10%. So if you have a 10% increase, this is the same as multiplying by 1.1. And then if you have a 10% decrease, this is the same as multiplying by 0.9. So here you've got 110% of what you started with, here you've got 90% of what you started with. So we can actually compare these multipliers here, and this is how I'm going to use the geometric mean to make sense of average change to my profit here. So what I'll do is, there's only two of them, so here n is 2, so it's just the normal square root of 1.1 multiplied by 0.9. So this is the square root of 0.99, and this is approximately 0.995. So what does this mean? Well, I guess if we convert this into a percentage then, so 0.995, this becomes 99.5%. And this 0.995, if I was to multiply by 0.995 instead of 1.1, instead of 0.9, this would correspond to actually it would be a 0.5% decrease. And this is because if you imagine what have I got left over, 99.5%, I must have decreased by 0.5%. So the geometric mean, this is kind of telling us that each year maybe it's a 0.5% decrease on average. So let's have a quick look at an example with some numbers. So let's imagine my initial profit first year was just £100. So then my profit the next year, I'd multiply this by 1.1, it would be £110. Then my profit decreases by 10% from that, so I'd multiply this by 0.9, and then what this would give me would be £99 when you multiply all of these. So you can see here the profit has actually gone down compared with my original. And obviously when we've done the arithmetic mean, this is giving us a 0% change, whereas the geometric mean, this is saying, okay, it's an average of a 0.5% decrease. So if we say that each year we did a 0.5% decrease, so multiply by about 0.995, and then multiply this by 0.995 again for the following year. Over these 2 years, when you calculate this, this will be approximately £99. And of course you could be more precise with your 0.995 if you didn't round there. So here you'll actually see that if you consider this going down by 0.5% each year as your average, then this will give you a more sort of reasonable answer. Whereas if you use the arithmetic mean, and you say that your average change was just 0%, you would say you've still got 100% profit in the final year. But we know that the amount of money has actually gone down there. Okay, so the geometric mean is really not used as much as the arithmetic mean, but hopefully you can see here at least that it does make sense to use it in this instance. And basically what's at the heart of this is the fact that we're comparing things, we're trying to take an average over things that are being multiplied together. So usually if you're looking at an average where it might make sense to add things together, certainly you might want to use the arithmetic mean. But then if you're looking at the geometric mean, this can be applied for things where you multiply them together. So percentage change, proportional changes, multiplicative changes, it might make sense to at least have a look at the geometric mean there if you're not adding things together.